Welcome to this video showcasing ELMG Digital Power's latest offering, the Control Scope. The Control Scope works on the Xilinx Zynq system on a chip and uses custom logic to gather signals and transfer them to the DDR memory. This is then read by Linux on the ARM cores and logged to an SD card and/or sent over the Ethernet to the Control Scope. It is designed to be used as a monitoring, logging, or debug tool running at the system sampling rate. Let's look at the Control Scope. Here I have it running signals from a three-phase test application. Looking at the channels and colors, we have the three-phase currents visible. These are from a logic ADC driver. We can also see ID or IQ, D error, Q error, or I alpha, I beta. The Control Scope has 16 channels which can be connected to anything inside the programmable logic. The Control Scope has standard scope knobs. It has a time per division to adjust horizontal scale and a volt per division to adjust vertical scale. As you can see, we move the time per division knob and the time scale changes. We move the volt per division knob and the voltage scale changes. These can also be edited manually. We also have a volt offset for vertical positioning. Which here I just reset it back to 0. This system has 16 32-bit channels, although not all bits are being utilized as this is only a 16-bit ADC. And they are color-coded for easy viewing. It has run and stop. When the scope is stopped, you have extra features. The first we have is the save option. It allows you to save the scope as an image file. There is also zoom, where we can zoom in on certain areas of the scope, and as you can see, you can look and you can see the X and Y values if you want to see particular values. You can also pan the image to move along to see other particular values. When we run, it goes back to the original settings. The Control Scope has a standard triggering with selectable source. Selectable level, as shown by the horizontal red line. So move it up and down, now become triggered. As we move it up and down, the system pans and we can see different trigger levels. We can also do time offset to move it back and forth, and the trigger point back and forth in time. We also have both positive and negative edge triggering, and as you can see, it changes as I change the edge. We also have 3 modes. The standard mode is auto. It just triggers all the time. Next mode is normal, which only will display when a trigger occurs. As we see, we're going back, there's no trigger occur, and we lose the display. The third mode is single. As soon as it gets a trigger, it will stop the system. As we can see, run this a few nodes, and since we're continuously getting triggers, the system just continuously stops. Set it back to auto and run it. Menu options allow you to select the channels you wish to receive from the Zynq. Reducing these reduces bandwidth if this is necessary for any reason. When you disable a channel, it is grayed. All changes only take place when it is stopped. So you can see it is grayed now. You also have select all and deselect all to disable and enable all channels. The other option is to load the config file. This defines the channel names, channel scales, and parameters like sampling rate. It also defines channel colors. Watch the channel names change as I change the config. Different configs can be auto-loaded on loading. In this case, I have the default is for a 3-phase system. Let's have a brief look at the Linux side. Along with the driver, there is a Linux app which talks to the scope, which we have named DLog. It has a number of options. It can be run in a variety of modes, including log into the SD card, sending it to the Ethernet, or even both. Let's start it up to talk to the Controlscope application via the Ethernet. And waiting for the incoming connection, run the Controlscope, and it's connected. Thank you for watching this video on the ELMG Digital Power Control Scope. For further information, contact Tim via the email below. Thank you.